Assalamu alaikum shabab. Okay, welcome again. Inshallah, today we'll talk about a new chapter which is called Stoichiometry. Okay, Stoichiometry. In fact, this is an easy chapter, okay, which deals with the chemical reaction or with the chemical equation. So, sometimes you will find and tricky questions at the exam about this chapter, okay, or about this topic. So, you have to divide these topics into four main subtopics. Okay, the first one will deals about equations and the balancing the chemical equations. Okay, equations. Next, remember we are talking about reactant and product chemical reaction. Okay, at this chapter, so you always have to remember that. So we deals with equation and its balancing, then masses, okay, of atoms or molecules or compounds. Then we'll talk about mole concept, okay, about mole concept, which include the number of moles, concentrations, molarity, and so on. Okay, mole concept. The second part here, we will talk or we'll deal with the topic of, we are talking about chemical reaction. So at industrial process, okay, it is very important to deal with products. يعني بيهتموا كتير في products at industrial process. So it is very important to talk about products and purity. If we, for example, making ammonia at industry, it is very important to talk about ammonia. Okay, reactant such as nitrogen and the hydrogen is very important also, but ammonia is specialized. Okay, it is very important. So we'll talk about its purity, percent of purity, okay, of ammonia, amount of ammonia result from the process, which is called percentage of yield. So these are the main 4 topics or 5 topics which we will talk at the chapter of stoichiometry. Okay, so firstly, let's deal with the equations and the chemical equation. Okay, so 1, balancing a chemical equation. And first topic from the 4 topics, balancing chemical equation. What's meant by balancing a chemical equation? Why is it very important to balance the chemical equation? Why? Okay, for example, balancing a chemical equation means you have to make the chemical equations like a balance. Number of reactant, okay, or number of particles at reactant equals the number of particles at product. Okay, so during the chemical equation we have reactant will give product. So number of particles here, or atoms or molecules, must be equal the number of product of a molecules also, or product. So for example, if you have an atom such as calcium react with chlorine, okay, as you see we have here 1 atom, okay, of calcium, and we have 2 atoms of chlorine. Okay, so will calcium atom need 1 chlorine or 2 chlorine atom? Okay, as you know, for example, calcium, according to the bonding, has what valence at its valence shell, 2 electrons, so it will need 2 chloride, because chlorine also, or chloride chlorine atom has a valence shell has 7 electrons, so it needs 1 electron. So we can say its oxidation number is -1, or its valency -1. So it will need also 1 electron only from chlorine. So calcium can give 2 electrons to chlorine, 2. Okay, so calcium will, okay, bonding with 2Cl2. So as you see the reaction here, we have here CaCl2, At this reaction, no balancing required because calcium, we have calcium atom, only calcium atom, but this calcium atom will give 2 electrons, okay, for chlorine, which is balanced. Okay, so this equation does not need any balancing. Okay, let's move to another equation which need balancing. Okay, for example, reaction of Mg magnesium plus oxygen. What about its balancing? The product of this reaction is magnesium oxide. الناتج بتاعها المغنيسيوم oxide. Okay, magnesium oxide. Why, Mr. Magnesium oxide? Because we talked about the bonding of magnesium and oxygen. We said that magnesium is group 2 element, so it will lose 2 electron. Okay, and oxygen is group 6 element. It will lose also. It will gain 2 electrons. Oxidation state -2. So oxygen will gain the 2 electrons of magnesium and form MgO, and form what? MgO. So back to our equation. How many atoms here of magnesium? We have here 1 atom of magnesium. Okay, at the other side 1 atom. Okay, it is good. How many atoms of oxygen here? We have here 2 atoms because O2. So at the other side, or the right hand side, we have 1 atom. So we should or must balance this equation by addition of 2 here. Okay, so now we have 2 magnesium because 2 is multiplied at magnesium and oxygen. So we have 2 magnesium atom and 2 oxygen atoms. So we have 2 magnesium here. In an easy way, before balancing, okay, you can do that. You can do number of magnesium atom here before balancing. Let's delete them. Okay, okay. You can write here at the left hand side magnesium atom here equal 1. Okay, and the magnesium here equal 1. So it is so easy, or they are equal. The left hand side number of magnesium atoms is equal the right hand side of magnesium atoms. Okay, so let's talk about oxygen. Oxygen here we have 2 atoms. Okay, oxygen the other side 1 atom. Okay, this is a problem here, so it is wrong. So what should we do? We will move to the lowest one, or the smallest value, which is 1, and multiplies it by 2. Okay, and increase the number of oxygen atoms here by 2. So we will add 2 here to increase it by 2. Okay, so now we'll move again here. We have 2 magnesium and 2 oxygen. Okay, because I said magnesium 2 is multiplied magnesium 1 time and is multiplied oxygen 1 time. So we have 2 magnesium and 2 oxygen. Again, we have here 2 magnesium. Oh, but here 1 magnesium, so we have to write here 2 magnesium. Okay, back to the first one and write here 1. Instead of 1, we write 2. So we have here 2 magnesium. So we should, or we must have at the other side 2 magnesium also. So we must write here 2. Okay, and add also only 2 before magnesium. These 2 methods are so easy, so you can balance an equation. Okay, let's move to the next topic. At our chapter, we agreed that this chapter is so easy if you classified it into 4 topics. Okay, second topics, which is talk about masses, if you remember that. Okay, second topic is talking about, yes, masses. So let's move to second topic. 1, 2, masses. Remember, always we have at this chapter a relation between reactant which give product, chemical reaction. Okay, so we'll deal with masses of products and the masses of reactant. Okay, or masses of reactant and masses of product. You have to understand that the reactant may be atoms, reactant may be atoms, okay, such as magnesium, for example, may be compounds, okay, may be compounds such as, for example, ethanol, such as the magnesium chloride, such as sodium chloride, magnesium chloride. They are all compounds. So we have to calculate the mass of atoms if it is found, if the reactant is found as an atoms, or found the mass of product of reactant as a compound if it is found as a compound. Okay, so also for masses of product also can found as atoms, okay, or molecules, also as compounds. Okay, you have to find their mass or the weight of products. Okay, so to talk about mass of atoms, okay, what happened? Okay, let's move to the mass of atoms. Firstly, mass of any atom, mass of atom, mass of atom is called in chemistry relative atomic mass. It's called what? Relative atomic mass. Called, يبقى mass of atom at the chemical reaction is called the relative atomic mass. Relative atomic mass. Okay, relative atomic mass of an element, which is the average mass of one atom. What's meant by average mass? As you learned at the previous chapter, any atom or most of atoms have what's called isotopes. What's meant that any atom can be found at many, okay, forms. So each form will have a number of neutrons, has a number of neutrons different than the other atom. يعني ممكن يبقى لها number of neutrons different than atoms الثانية. Such as, for example, carbon. We have carbon C14, for example. We have C12. Okay, and also, so when you have to find the average atomic mass, we have to calculate, okay, or sum the percentage, okay, of, or the mass of the two atoms, atomic mass of the two atoms, and divide them by 2, for example. Okay, then you will have the average atomic mass. So at all, mass of an atom at chemistry, mass of an atom at chemistry equal or called relative atomic mass, okay, which equal, as you know, from hundreds of years ago, the first elements which were discovered is carbon. So they compared each element discovered after that with carbon. So can say relative atomic mass, the average can define it as, again, mass of atom, average atomic mass, okay, or the average mass of atom, average mass compared to C12, carbon atom. Okay, so if one of the reactant is atom, you have to calculate the mass of these atoms. So what if it is molecule? If it is molecule, what will happen? Okay, also if the one of the product is molecule, okay, such as if the reaction between magnesium and oxygen, okay, if it is molecule, okay, the mass of molecule here is called, okay, relative molecular mass. Relative molecular mass. If it is molecule or compound, molecule or compound, okay, molecule of compound. If one of the products or reactants is molecular compound, such as H2O, such as O2, NaCl, okay, so we deal now with a mass of compound or molecule, not atom, and in this case is called molecular mass, or a compound or relative molecular mass. Okay, chemistry, molecular mass, also called relative relative, so let's delete it, relative molecular mass, So if we have a reaction, okay, between sodium, for example, and water, it will give us, as you know, sodium hydroxide, NaOH, sodium hydroxide, okay, plus H2 or plus hydrogen. Okay, from the calculations in chemistry, you have to calculate. If we calculate the mass of sodium, it is called a relative atomic mass, relative atomic mass, relative atomic mass, okay, and you can obtain it from the periodic table directly. If you want to calculate the mass of the sodium here at this equation, you will move to the periodic table and search for it and find it at the periodic table and write it. Okay, so if you move to the periodic table, you'll find the relative atomic mass of sodium is 11 or 11 point, I don't remember, okay, but maybe 11. Okay, so what about H2O? You have to remember that H2O is a compound, so its mass equal, okay, what's called the relative molecular mass, relative molecular mass, okay. So how can I calculate the relative molecular mass for any product or for compound? So relative molecular mass of water equal, okay, also we'll move to the periodic table, but remember, you will sum all masses of the compound, all mass. We have here 2 hydrogens, so 2 hydrogen here, 2 times, if you move to the periodic table, you'll find that the average atomic mass for hydrogen equal 1, then plus, if you move to the periodic table, plus the sum of atomic mass of oxygen. If you move to the periodic table, you'll find the atomic mass or the average atomic mass of oxygen is 16. Okay, so here 2 multiplies 1, 2 plus 16 is equal 18. So here the relative molecular mass, okay, for H2O or for water is equal 18. So now we make a balancing for the chemical reaction. We calculated the relative atomic mass for products, and we can do it for products only. Okay, we can do that for product also, as we did for reactant. Okay, so now we talked about the first 2 topics at stoichiometry, which were balancing chemical equation, calculation of relative atomic mass and the relative molecular mass, and we know the difference and their importance. Okay, the next topic we'll talk about moles, concept mole. What's meant by mole? Mole comes from the molecule, okay, so it will deals also with product. Remember, also we have to talk about chemical reaction, which is which contain reactant and the product. Okay, so you will calculate the number of moles of reactant and number of moles of product. So which is the number of moles of any product? Okay, number of moles or a mole, okay, it is a molecular mass expressed in gram. يبقى المول also is a mass, but a mass of certain number of molecules. So again, what is the difference between moles and grams? Mister, we talked about calculation of masses, and we said we can obtain the masses or the relative atomic mass from the periodic table. So what about mole? What about the concept mole? Okay, concept mole, he talked about the mass, okay, mass of a certain number of molecules, of a particular number of molecules, يعني they got a certain number of each molecule. For example, okay, 6.1 times 10 power 23, okay, power 23 يعني ممكن كده مليار مثلا molecule from sodium and say that it is 1 mole of sodium, and also billion number or مليار برضو from magnesium and said that مليار equal 1 mole, and they got billion of مثلا water and said billion molecules of water equal 1 mole, and so on. So they put a number of molecule which is equal to 6 point or point 22 times 10 power 23. This is the number of molecules. They took a number of molecules which equals 6.2 times 10 power 23 of anything, of any compound, of any element, and said that, and with that or calculated their mass, and they said that the mass of water equal, or the average, the number of moles of water equal كذا, and the number or the moles of sodium equal كذا. So they said that 1 mole of sodium, 1 mole of, so for example 1 mole of sodium Na, their mass 23. Their mass 11. Sorry. Their mass, yes, their mass 23. See, we had a great mistake here. We calculated the mass or the atomic mass of sodium 11, so it is 23. It is 23 here, 23. So back to our calculation. 1 mole of sodium equal 23 grams. So there is a relation between mole and grams. Again, number of moles and its relation with mass. They took a certain number of molecules and weighed it from all substances. And say for example they take مثلا 6 molecules of sodium, their weight 23. They take 6 molecules of magnesium, their weight 12. They take 6 grams of water, their mass 18. They take 6 grams of sodium hydroxide, their mass equal كذا. خلاص يبقى so number of moles or 1 mole equal mass of a certain number of particles, which calculated or which put as 6.2 times 10 power 23 molecules. So 1 mole of any atom equal its atomic mass. Atomic mass. 1 mole of any molecule or compound, 1 mole of compound, let's read this, one mole of compound equal what? Equal sum of its atomic masses, or average atomic masses. For example, 1 mole of sodium hydroxide, NaOH. 1 mole of sodium hydroxide equal mass of 1 compound, mass of NaOH, which equal mass of sodium, as we said, the relative molecular mass, which equal 23, oxygen, 16, hydrogen 2, at the end it will equal 18 plus 23, 23, 8, 1, 2, 4, 2, 41, maybe equal 41. So 1 mole of sodium hydroxide equal the mass of 1 mole per gram, per gram, per gram. So we have a relation to obtain the number of moles of anything. if you have any substance or chemical substance, a product or reactant, number of moles of it, number of moles of it equal its mass, K per gram, division its the molecular mass, MR, molecular mass, or the mass of 1 mole, the mass of 1 mole, as we said, okay, MR, or the mass of 1 mole, mass of 1 mole, mass of 1 mole, or mass of 1 mole, okay. That's what's called MR. Equal also mass of MR, mass of 1 mole equal relative atomic mass, from the periodic table if it was an atom, or molecular mass, okay, or the sum of atomic masses. Okay, so it is easy. So number of moles of any substance, if I give you any substance, for example, okay, if I asked you calculate the number of moles, example, okay, calculate the number of moles of, okay, 46 gram sodium. You have 46 gram sodium, calculate the number of moles. ايه النمبر of moles بتاعتهم؟ Just you will move to the relation which is say number of moles equal mass per gram, mass اهي per gram over, we're talking about sodium, okay, equal MR or ER. We said MR from the periodic table equal the atomic mass if it is element such as sodium, equals the sum of atomic masses if it is a compound, يعني مجموع atomic masses لو compound. خلاص, it is easy. Okay, by compensation. Okay, mass of sodium as the equation is 46, so 46 MR from, if you go to the periodic table, or you will find the atomic mass for sodium is 23, so 46 over 23 equal 2 mole. So number of moles of 46 gram equal 2, number of moles of 46 gram equal 2, okay, number of moles equal 2. Thank you. Okay, so now we talked about 3 topics, which first one was masses of the product and reactant. Next topic was balancing, or first topic was balancing chemical equation, then atomic masses, then the number of moles. So let's move to another topics. But before moving to the another topics, okay, we have to talk about what's called concentration. Okay, as you know, to understand, also to study the chemical equation which contains reactant and the product, okay, we may talk about solutions, not all the masses, about volumes. Okay, if we talk about solutions, it's very important to deal with the concept concentration. So يعني ايه concentration؟ الكونسنتريشن ببساطة هو relation ما بين، concentration ده هو relation ما بين the number of moles concentration of any substance. If you put sugar, for example, sugar inside مثلا water, sugar inside water. What about the concentration of sugar in water? Okay, concentration here you are deals with about what? With number of moles of sugar, okay, number of moles, and you understand now how to obtain number of moles of sugar. Sugar is a compound, have the formula, for example, C6H12O6, like glucose, H12O6. You can get the number of moles of it, okay? So number of moles over the volume in decimeter cube بالديسيمتر كيوب over the volume. okay بالديسيمتر كيوب. decimeter cubed equal 1000 centimeter cube equal 1000 centimeter cubed. okay, so again, to calculate the concentration of sugar in this solution, you have to calculate number of moles of sugar, and you understood how, over the volume of the solution, the volume of the solution. okay, so let's take an example for the concentration. If he asked you if you have hydrated copper 2 sulfate, okay, hydrated copper 2 sulfate, found the concentration, okay, of 2.5 gram of hydrated copper 2 sulfate, CuSO4, okay, 5H2O, 5H2O. Calculate or find the concentration of 2 grams of copper 2 sulfate, okay, in what? In 20 or 250 centimeter cube of solution of a, يعني you have a solution, okay, you have a solution which have CuSO4, H2O, okay, 5H2O, and dissolve it in water. okay, you have here volume of solute or volume of solution equal 250 centimeter cube. okay, you have here the mass of copper sulfate or hydrated copper sulfate, okay, hydrated copper sulfate, hydrated copper، الماس بتاع الهيدريت كبر سلفيت ده سوليوشن عادي جدا في ماس معينه من كبر سلفيت، ديسولفت دوبناها في فوليوم معين من الووتر. السوليوشن في النهايه يبقى الفوليوم بتاعه 250 سنتيمتر كيوب، خلاص، والماس 2.5 جرام. هو هنا عاوز بقى ايه؟ هي وانت كونسنتريشن، هو عاوز الكونسنتريشن. اروح طبعا اكتب له الريليشن بتاع الكونسنتريشن واقول له انت قلت لي الكونسنتريشن بتاع any substance، okay، equal number of moles over volume بالديسيمتر كيوب. لازم نركز على دي، please focus on those, focus on this point. decimeter cubed is very important, which equal 1000 centimeter cube. I read it for the first time. okay, so do we have here number of moles? Do we have volume? okay, we have mass. We have here mass, not number of moles, but we have volume. okay, we have volume, it is easy. So how can we change mass to number of moles? okay, it is so easy. We can change mass to number of moles. Firstly, here, okay, what is the relation between mass and number of moles? We have number of moles equal mass over what? Over molecular mass, MR. Again, remember, molecular mass equals the sum of atomic masses. okay, so we can calculate it. Mass equal 2.5. Sum of atomic masses, remember we are talking about compound called CuSO4, okay, 5H2O. We're talking about that. okay, so you have to calculate all the masses of those atoms. Sum the mass of copper plus sulfur plus oxygen, 4 oxygen, 5 water, and so on. okay, so mass of copper equal what? Equal 64. okay, mass of sulfur, sulfur 32. okay, 4 oxygen الاكسجين 1 اكسجين ب 16 يبقى 4 اكسجين بكام؟ 64. اوكي بلس كام؟ بلس بقول لي 5 H2O 5 تايمز H2O يبقى 5 في H2O الواحدة هنا 2 بلس 18 بلس 16 يبقى 18 يبقى ال H2O الواحدة ب 18 اوكي ب 18 يبقى 5 تايمز 18 5 تايمز 18 at the end you will find that okay number of moles equal كام equal to 150 blood gram. Okay, so we have here number of moles, we have here number of moles. Okay, we can move again to our first equation. First equation said what? Let's transfer this here. Volume decimeter cube. We calculated number of moles, if you remember, 200, okay, 50 grams, 250 grams. Okay, so or the atomic mass is 250 grams, so number of moles equal here, number of moles equal 2.5 mass per gram over 250. okay كل ده over كام؟ الفوليوم بقى، كل ده over مين؟ over الفوليوم اللي هو 250. but remember volume decimeter cubed and we have at the problem with centimeter cubed. We have here with centimeter cubed. Okay, so we have to change centimeter cube or into decimeter cubed by division on a 2000, by division into 2000. Okay, so here to 1000. Okay, so the final product here I wrote it by this method to understand it. Okay, if you put it at your calculator, okay, you can calculate it, and you can calculate the concentration by using calculator. Concentration equal, okay, 0.04 mole per decimeter cubed, because we have here mole and we have here decimeter cubed. Okay, so now we calculated the concentration. We calculated here the concentration, which equal concentration in a substance, okay, which equal number of moles over what? Over volume per cubic decimeter. And inshallah the next time we will talk about yield or percentage of yield and purity, which is the last topic or the last two topics at stoichiometry. And by this we finished our session or our first session about stoichiometry. Thank you my dear students, thank you for listening. Inshallah we will meet again بإذن الله. Okay, thank you.